Welcome to the Core 2 video for evaluating functions with expressions. The paper we're using, originally I had developed for us to work on fractions and functions. I did another video on fractions, so we're not going to work on these fractions. If you want to find the Core 2 video for evaluating functions with fractions, that will tell you how to do the first core problem. This video, we're going straight to the problem number 5, evaluate each function at the number. And actually that is on the other video as well. The other video starts with that. So I will skip the ones where we just evaluate with a number. I want to go directly to number 7. Number 7 is kind of complicated. We evaluate it at a whole number, but the function is not given in terms of the variable. The function is given in terms of an expression, and that complicates the issue. So first of all, I will zoom in so that we can see what we're working on here. W of n minus 1. So W is a function of n minus 1. It's not a function of n. Fundamentally, it is a function of n. And we could find that function, W of n, but we really don't need to do that to solve this problem. We need W of negative 6. And that tells me that n minus 1 has to be negative 6. So what I want to plug in a number that makes n minus 1 equal negative 6. I can find that number now by solving the one-step equation. N equals negative 5. So to get this, I plug in 2 times negative 5 squared plus 2 times negative 5. And then at that point, I evaluate it just like I normally would. So I'm not plugging in negative 6. I'm plugging in negative 5, which gives me negative 6 here. Negative 5 squared, of course, is negative 5 times negative 5. Gives me 25, positive 25, because a negative times a negative is a positive. You need to think about that if you're using your calculator. You put negative 5 in your calculator without the parentheses, it will square 5 and then make the 25 negative. That's not what this expression says. You have to put the parentheses if you're putting it in your calculator. And when you write it, you have to put the parentheses as well. Okay. 2 times negative 5 is going to be negative 10. So W of negative 6 equals 50 plus negative 10, or 50 minus 10. 50 minus 10 is 40. Look that over and pause the video for a moment. Try number 8. After you tried number 8, come back and check your answer, and then we'll go on to number 9. Okay, now that you've worked problem number 8, coming back, we want to find k of 1. So I have k of 1 equals, and I don't know what x is, but I know that when I add 2 to x, I will get 1. I want k of 1. I need to make x plus 2 equal to 1. Now I subtract 2 from both sides. And I plug in negative 1 for x. If I put negative 1 here, negative 1 plus 2 gives me a positive 1. I will get k of 1, but I have to plug negative 1 in for x. Negative 1 squared minus 5. Negative 1 squared, negative 1 times negative 1 is positive 1. Positive 1 minus 5 gives me negative 4. If you didn't get that answer, think about it for a moment. See if you can figure out what you did wrong. And then go on to number 9. Pause the video. See if you can answer number 9. All right, now that you've worked on problem number 9, you've come back. We need to find k of 5. So I have a function k. It equals n squared minus 5. I want to see what k of 5 is. But k of 5 doesn't mean plug in 5 for n. Oh, to get k of 5, I need for n minus 3 to equal 5. Add 3 to both sides. And I get n equals 8. So if I want n minus 3 to be 5, n has to be 8. So I plug in 8 wherever I see n. Eight squared is 64. 64 minus 5 is 59. Once I figure out n, it's just a matter of plugging it in. Pretty straightforward. It's a little complicated to see what n is to figure out what the variable actually is, because I'm not given the function in terms of n. Okay. Try number 10. Pause the video, try number 10. When you come back, you can check your answer. Okay, now that you have worked number 10, we need f of 0. That does not mean n equals 0. That means n plus 2 equals 0. My function is given in terms of n plus 2. It's not given in terms of n. So I need to say n plus 2 equals 0. N equals negative 2. Okay. So I come back up here, f of 0. To get f of 0, I need to make n negative 2. Negative 2 plus 2 does give me 0. If I make n equals negative 2, I have negative 3 times negative 2 squared plus negative 2. Negative 2 squared, negative 2 times 2, negative 2 times negative 2 gives me positive 4 squared, because the negative times a negative is a positive. So I get negative 3 times 4 plus negative 2. Negative 3 times positive 4 is 12, but negative times a negative is a positive. Negative times a positive is a negative. Plus negative 2. That's the same as saying minus 2. You can think about it either way you like. Either way, negative 12 minus 2. I'm 2 below negative 12, which is negative 14. Go on to problem number 11. Pause the video, take a quick look at this, and then go on to number 11. And work that, then restart the video, and you can check your answer. Okay, number 11, we're into a new category now. We evaluate the function at the expression. So it's different than number 10. Number 10, I had an expression in the function. Instead of x, I had x minus 3 or x plus 5. Now I have a straightforward function, f of x equals x squared minus 2x. But they want me to plug in an expression. I don't have to find the number to plug in. I'm not going to plug in a number. I'm going to plug in 4 plus x. So f of equals, plug in 4 plus x wherever I see x. I see 2x, I plug in 4 plus x. And I left off my squared. Okay. I had x squared here, I need 4 plus x squared. And that in itself, I have plugged in, I have an expression for f in terms of 4 plus x, but it doesn't look as nice as it could. We've done a lot of things that we can to put things in standard form, and that's really what we have to do now. Get rid of parentheses and combine like terms. First of all, to get rid of parentheses when I have 2 times 4 plus x, I multiply 2 times both of them. And I'm subtracting both of these, so they're both going to be minus. Minus 8 minus 2x. Or you can think of it as distributing a negative 2. Negative 2 times positive 4 gives you negative 8. Negative 2 times x gives you negative 2x. To do 4 plus x squared, I'm first going to write 4 plus x times 4 plus x. 4 plus x squared literally means 4 plus x times 4 plus x. Now, I'm going to do the area model. If you like to do FOIL, you may. If you want to think about the distributive property, you can distribute it 4 plus x over the 4 plus x, and then distribute each of those back over. Area models work well. I'm going to say the top is 4 plus x, and the left side is 4 plus x. So my area of the whole rectangle is 4 plus x times 4 plus x. So my whole area is equal to that. I'm going to calculate my individual areas. 4 times 4 is 16. 4 times x is 4x. So this area is 4x. This area is x times 4, which is the same as 4 times x. I also have 4x. And lastly, I have x squared, because this side is x, this side is x. The area of the rectangle is x times x, or x squared. So I will go back to my equation. And instead of 4 plus x times 4 plus x, I will write x squared. And I could write plus 4x plus 4x. I'm going to do that in my head and say plus 8x plus 16. Now I have to subtract the rest of the equation. Minus 8 minus 2x. And that gives me some more like terms to combine. F of 4 plus x equals x squared. I have 8x and I have minus 2x. Have 8 x's, lose 2 x's, I'm left with 6 x's. I have 16, I lose 8, I end up with plus 8. So f of 4 plus x equals x squared plus 6x plus 8. Okay. Pause the video now. Think about that for a moment. See if you can do problem number 12. Once you've done problem number 12, come back and you can check your answer. Okay, made you think a little bit on problem number 12. Problem number 12 is g of x squared. We have to plug in x squared. We raise that to the third power. Plus 3 times x squared. So I plug in x squared. Wherever I see x, I put in x squared. Just like with a number, if I see x, I put the number in. I have an expression now. I want g of x squared. Wherever I see x, I plug in x squared. g of x squared equals, you'll have to think back for this one. I'm going to say third power means x squared times x squared times x squared plus 3 times x squared. And my x squareds now, I'm going to take an additional step in here. If you remember how to do this, you don't necessarily need to put this step in, but x squared means x times x. The second x squared means x times x. And the third x squared means x times x. And I still have plus 3x squared. I'll keep that there. And now I'm thinking, okay, if I'm multiplying 6 x's together, exponents mean this is how many you multiply together. I can call this g of x squared equals x to the 6th power plus 3x squared. Okay? And I will leave it at that because there are no parentheses, no like terms. That is standard form. Okay. Let's try number 13 now. See what you can do with number 13. Pause the video. Pause the video and work on number 13. Okay, now that you've got an answer for number 13, let's check and see. You're plugging in the expression n plus 2. So if I evaluate the function at n plus 2, I have to I plug in n plus 2 for 2. And you'll notice this is pretty similar to number 11. Okay? G of n plus 2 equals, once again, I'm going to say n plus 2 squared. That's just a short way to write n plus 2 times n plus 2. When I see it that way, it's more obvious that I need to do the area model. Plus 5 times n plus 2. So I do my area model. The top is n plus 2. The side is n plus 2. I'm going to represent this product, this multiplication, I'm going to represent that as an area. So n plus 2 times n plus 2, I get the area. That's the same as n times n plus 2 times n, 2 times n, plus 2 times n, plus 2 times 2. I can take those numbers now, plug them back in. G of n plus 2 equals n squared plus 2n plus 2n plus 4. And when I do this, 5 times n, I say plus 5n, and 5 times 2 plus 10. I combine my like terms now. Equals only one n squared. I have 2n plus 2n plus 5n. 4n plus 5n is 9n. I say plus 9n. And then I have plus 4 plus 10. That is plus 14. After I get rid of the parentheses, I combine like terms. I have my standard form, n squared plus 9n plus 14. I think we have one more. We do. 14. Try 14. Pause the video. Come back and check your answers. Okay, now that you've gotten an answer for problem number 14, we plug in our expression. G of a over 2. Wherever I see a, I put a over 2. Plus 5 times a over 2. If I want an expression for, if I want a function that relates a over 2 to g, I plug in a over 2, and a over 2 squared means a over 2 times a over 2. I'm being careful to make my a's look like a's, not 9's. These are a times a plus 5 times a over 2. So g of a over 2 equals. When I multiply fractions, I multiply the numerators. A times a is a squared. 2 times 2 is 4. Plus, I'm going to make this a fraction really quickly, 5 over 1. Helps some people think through it. So I have a fraction, I multiply the numerators. 5 times a is 5a. 1 times 2 is 2. I have eliminated the parentheses. I have combined like terms. Really didn't have any like terms. If you want, you can write this as a over 2 equals 1/4 a squared plus 5 halves a. Either one, though, is an acceptable answer. Thank you.